Hello. Hello. Welcome in. Actually, you reminded me I have to post in Cody's Discord. So we're gonna work more on that Limbo plugin. Alright. Yeah, although I do think... alright. I do think perhaps I've gotten a little carried away with this. I mean, it's a pretty big, part 1 was quite long. But it happens. Alright. Let's just get right into it, right? So what happened last time? We got our schematic loader to read Sponge v3 schematics. I copied it right from my prison core, and we made our own NBT reader as well, because Papers has a limit to how big the schematic can be, or at least I think. When I was working with my prison core, I used Papers NBT reader initially, and it worked just fine until I added a bigger schematic, and then it took way too long to load. So I ended up making my own, and it worked pretty great. I mean, if you've seen the showcase videos from my prison core or any of the streams, you'll see. Pretty quick. It loads it into memory on server start. So that's, you know, and then it just reads from that every other time it gets sent to a player, which is what we're going to be doing here. We already have the storage for it in the iFake block handler, or I guess the fake block handler. We got a NMS setup here. If you missed the last stream or haven't seen it yet, that's what we've done so far. And yeah, so it stores all the blocks per chunk section, per chunk. And I believe we finished the schematic loader. We just haven't done anything with it yet. After we get the schematic loader, we need something that'll call it, and that's the schematic manager. We have a load, which adds it to the schematics set. So we can easily look up if a schematic is loaded or not. Although we could just use the fake block handler because we're also storing it by schematic ID there, so I think I'll change that up. Let's just go our abstraction module, go to our fake block handler, and we can just go and say is loaded, and we'll pass in a ID there. Okay. Get rid of those imports, don't need them. Related problem, yep. So now we override it. There you go. Now we can simply say world contains schematic ID. And we're gonna lowercase that. And not contains, we want contains key. Alright, and I'm gonna rename this from world to schematics. Alright. There we go, that's all set up. And now we can get rid of, well, not get rid of, but we can add our fake block handler. Okay, fake block handler. NMS factory, get NMS handler, get big block handler. There we go. And now we can just, we're not gonna get rid of this exists method, but we're just gonna change it. Schematic loaded ID. There you go. Okay. And I'm gonna be honest, I think this music is a little loud. Is the music too loud? How's the music volume? It's a little loud on my end. I think I turned it down my last coding stream for me, but I left it the same for the stream. It's a bit too loud? Okay. I'll turn it down. Alright. What's that? I only turned it down 1%. It was already only at 3% to begin with. Okay, 1%? Like that? Definitely background music now. Okay. So... we can get rid of schematics set because we don't need to check that. Although, here, I think we can probably get it ready today. Yeah. We do need a way to load the schematic and send it to a player, so we do have to do some packet listening and all that stuff, so that might take just a little bit. Yeah, I'm not 100% sure. Depends on how long I stream. We'll see. We'll see. Probably. Alright. Let's keep that how that is. Alright. Might have to add a couple more. It's schematic IDs. Okay, import that. Okay, we're gonna go to our loader, load path there. We don't need that. So this throws an IO exception, so we're gonna simply put it. Oh, we already loaded it. Never mind. That's all we need then, right there. We need a return. Okay. All right. On reload, we need to clear out. We need to remove. Well, there's a remove schematic thing right there. I'm gonna go up here, move that to there. Another clear schematics. I believe that works. Okay. So now we need to add those. We're gonna say remove schematic ID. We're gonna make this lowercase. We always want to make sure that the schematic ID is lowercase. That way we don't have to worry about that. Put that there, okay. Public would clear schematics and schematics clear. That's it. And we have one more, which is get schematic IDs. Say set.copy of schematics set. There we go. Alright, now we're all done with that. Clear all schematics in the reload. Alright. This will allow you to choose different schematics as well. I mean, obviously, but we do have a specific schematic in our config. So we'll probably just stick with the one. We could probably make it oh. Don't join my Discord. Welcome in if you're watching. Okay. So we do have one schematic here. But it would be good to, I think what how do I want to do it? Because okay, I'll just keep this how it is. No, don't ask yet. We'll keep that how it is, and we'll use that for the automatic send to Limbo, and I'll have a command to send it to Limbo with different schematics. I think we'll do that. That way we can actually utilize the fact that we are storing more than one schematic. Okay. So, with that, let's just create a command. Say commands. Let's first create a, let's actually go to our common module. And we'll create some command stuff here. Commands. I'm gonna say command manager. Final class. Singleton. Okay. Private command manager. That's not how it is, it's that. Okay. And now we can do a register and here, but we do need something to pass in there. So we're gonna go here and we're gonna say abstract command. I'm gonna call it, I'm making a new class there. Let's say abstract class. And what we need to return, or what, you know, the abstract stuff we need a label, or, you know, a name for the command. I'm not gonna actually call it name, private, and we'll do aliases. And we have a description string as well. Only is final, not null. Then final, not null. Null. Okay. And do public get name. Public null. Get aliases. I'm gonna make a copy of it. Public not null string description. Okay. And now we want a constructor. Public abstract command. So we will obviously pass in a string of, you know, for the name. String aliases and description. Okay. This dot name equals name. This dot aliases. I'm gonna copy it. I think we can do copy of. Let's dot copy of instead of new. It won't be an array list, but that's fine. We don't need it to be modifiable. That's the description. Okay. Now let's make one more constructor. So abstract command. We'll pass in the name. And then we're going to pass in a string array of sorts of aliases. And this won't have the description. I'm going to say name equals name. This aliases equals list dot of aliases. Okay. And then we'll say description. Actually, what we can say is this. And we can pass in name list of aliases. And then we'll pass an empty description there. I think we can say strings empty. I don't see why I use this over just that, but it's the same thing. It's literally the same. Anyway, it's the same thing. I don't know why people would prefer this over just an actual empty string, but you know, whatever. Use whichever one. Okay. So now we have two constructors. We have some getters, and we need the actual. We're gonna make these final, these methods, because you don't need to override them. And then here's our abstract method. We're gonna say abstract. No. We're gonna return a literal command node, and inside of the generic brackets, we're gonna pass in command source stack. And make sure you want to import the one that's from paper, not from NMS. So paper command source stack, and we're gonna just call this root. Okay, and then obviously since abstract, we don't put a body for it. We just say that. Okay. So now this one's done. We can close out of this abstract class now. And then register, we're gonna pass in abstract command class that we made. And we also need a life cycle event. It's one of these two. Let me check my prison core. I'm doing this off memory. Okay. Yes, it's lifecycle event manager. And it is we'll pass in not null. Alright, sorry about that. Little brother came in asking what time it was. Okay. Right, and I just call this, I'm just gonna call this manager. Okay. In our constructor, a private constructor, we're gonna say manager equals, and we made a getter for our plugin. So in Limbo dot get plugin, okay, and then get lifecycle manager. There we go. If you don't know what this is a pretty helpful paper thing to register commands. Because if you weren't aware, paper-plugin.yml, you can't put plugins in here, or you can't put commands in here. They won't do anything. You have to register them through code, which is not hard to do at all. As you can see, this is pretty much it. And this register method is all we have to fill out now. So now we say manager register event handler. Life cycle events with an S. Dot commands in all caps. Okay. And then you say event. You make a lambda body. Okay. And we don't actually even need the body. We just need it to be a lambda. And we say event registrar dot register. Okay, I'm gonna say command. We're gonna pass in the root from our command, and our description, and then our aliases. Okay, and then we're done. That's how you register a command in paper, especially for creator commands. We're gonna make this final and not null. So that's our command manager. We're all done there. We're done with our abstract command, and now let's actually make our first command in our plugin here. We're gonna call it Limbo end. Okay. Right, we're gonna make this final, and it's gonna extend our abstract command we made. All right, and then we're gonna implement methods. We have to implement the root, and then we're gonna create constructor super. Doesn't matter which one you pick because we're gonna remove these parameters here. And instead, we're going to manually pass in whatever we want down here in the super call. So the name, I'm going to say Limbo, aliases, list of, and I'll just say, we're just going to do it in empty lists. We don't need an alias for such a small command or name. In description, I'm going to say, send a player to Limbo. Okay. Alright, so that's our constructor setup. Now, we gotta set up our actual command. So how do we want to lay out this command? We're gonna do limbo, and then we'll have limbo send you to the default schematic, and then we'll have schematic send you to a specific schematic, and then we'll have limbo schematic player send a player to a specific schematic. All right, and now let me show you how easy it is to make a command like this with Brigadier. I guess, you know, however you want to say Brigadier. I'm pretty sure it's Brigadier because it's spelled with an I right here. Brigadier. All right. And it's like if you ever used Lucco's library, he calls it Commodore. So it's like a Commodore and Brigadier, you know, like army ranks or something like that. Anyways, so we're gonna, instead of return null, we're gonna say commands. So you import from paper, not net.minecraft commands. Don't import that one. Import the one from iopaper mc.paper.command.brigadier. We're gonna say commands and then dot, and then we're gonna say literal. And inside of the literal, what this is it's saying you have to literally type this string into your, you know, chat bar. In the root node, always has to be a literal. You can't have a non-literal string as your first, you know, because this is like the command that you're gonna type, right? And any parameters of the command, like the schematic or the player, you can have after you type the initial command. So for the literal, we're gonna say get name. So that'll be /limbo. Okay, you see it's returning. It has a red underline here. That's because we want to return a literal command node, and this right now is a literal command argument. It's a literal argument builder. So that means you have to put .build at the end, and it'll return the node. Right? But we're not done with this yet, so I'm going to go ahead and press enter here, get it on a new line. And then we're going to say executes, dot executes. And inside of this dot executes, we're going to say context. And we're going to do a lambda body here. And we're going to return 1 there. Alright. And instead of return 1 or 0, I'm pretty sure 1 is success. I'm going to go to abstract command. I'm going to say public static final success. And make this an int. Public static final int failure. Okay, static success equals 1, failure 0. And I'm gonna actually switch these around there. Okay. I can go here, and now we can say return success. There you go. Now we know every success will be a 1, and we can just return success. Don't have to worry about remembering that it's a 1, even though I think you should forget that. Anyways, it's just a little bit of readability there, and allows you to manage it easier. I don't normally do that, but I figured why not. Okay. And I normally don't ever return failure in my commands either. I think if you return failure, it's supposed to do something, which I don't like. So I always return success and handle it myself manually in the command. Okay. So in the limbo command, we want to send ourselves to the default schematic. So first off, schematic manager, we're gonna go here. I'm gonna say default schematic ID, and then in on reload, we're gonna go. Okay, we're gonna grab the config from common, get config.yml or get config.yml, and we're gonna say default schematic ID equals config get config options get string, and we had it labeled schematic, and we're gonna rename it. We're gonna default to limbo, which is or we're gonna default to limbo.schem. Actually, just limbo. Which means we want to replace that as well. Okay, so no, schematic IDs don't have the file extension. Alright, that's our default schematic ID. Alright, and this shouldn't be final or whatever. And we're going to call on reload in our constructor. And then we can go here, we can say public get default schematic ID. If default schematic ID is null for whatever reason, then just return limbo. Otherwise, return default schematic ID. Which we can actually just simplify this like that. This is essentially saying the same thing. Return. If default schematic ID is null, then return this hard-coded string. Otherwise, return the default schematic ID from the config, which we grab here. Okay. Which reminds me, in our main class, or our main class, we're gonna create a public void on reload method here. Notice we're not overriding it. That's because Java plugin does not have an on reload method. So we're creating our own here. And we're gonna say config dot I'm gonna go ahead and say save file and then config.yml reload. Save file shouldn't save it, shouldn't change anything if it already exists. And we're not calling this one because this will load our file configuration to the config on the server, which would override any changes that we made in the config. We only want to do this if we're working with a file that we're changing through code, and then we would call that, but we're not, so we don't need to call that. So after we reload the config, we're gonna go do the schematic manager, get instance, and on reload. So now that's being reloaded as well. And then we'll call this in in an admin command. All right. Schematic manager. Okay. I think we're good. Let's go back to our limbo command. Well, actually, we need the world, right? We created a world in here in our main class, which should be fine. But we never. Where did we create that? Right here. All right. So we need to actually store that. So private world, limbo world equals that. There we go. And we're gonna go to our commons, and we can create a nullable world, limbo world, get limbo world. There we go. And then in our plugin, obviously, override public nullable world, get limbo world. And the only reason you need to ever add it to your common interface, like I just did, is if you are expecting to use it in other modules, which I'm not, but I added it there just in case, because our command is in our main class, which is or our main module. So technically, didn't need to add it to our common interface for this specific use case. That's how you can if you want to. All right, so we're gonna say how do we want to do this? Let's say first we're gonna check if the sender is a player, right? So if context, or sorry, if not, and then you have to put another layer of parentheses. Get source, get sender. That's our command sender. Instance of player, and then we're gonna create a pattern variable here by saying player again. That just defines the name of a player variable if there is one, and we're gonna say return desks, you know, and then we're gonna say limbo get plugin get logger info let a schematic, and then we're gonna return. Okay. And we can actually go here and say private Java plugin, and then plugin equals, and we actually don't need limbo.get plugin. We have our main class already here. Limbo plugin get instance is what I meant. Okay. And then I can just say plugin get logger. All right. And I have to call get instance on it every time. We just have it up there. And we can make this final, of course, and not null because it shouldn't be null. Okay. So this is what happens when the console just types /limbo. We'll send a message to it saying to select the schematic. Okay, and then if it's a player, then we're gonna send the player to the schematic. And what we're gonna do, I'm actually gonna go down here. I'm gonna say send player to schematic. I'm gonna say player, I'm in there. Okay, so we want the world. I'm saying limbo world equals limbo plugin. Well, we're gonna have to rename this from Java plugin to limbo plugin. So I don't have to change anything else because limbo plugin is a Java plugin. The only thing is I am saying that instead of Java plugin. Instead of downcasting it to a Java plugin, or just I think that wasn't an upcast. I don't know. Instead of casting it to a Java plugin, because get instance actually returns a Limbo plugin, not a Java plugin. Instead of casting it to a Java plugin, We're going to keep it as Limbo plugin. That way we can access the get Limbo world method without having to, you know, call get instance again. So if Limbo world is null, we're just going to return here. Do nothing. And then we're going to say Limbo world get spawn location. I'm going to put that in a variable. I'm going to call it spawn. Right, and then we're going to say player teleport to spawn. There we go. And we can actually put this out of a variable because we're not using it anywhere else. We're just going to teleport them to the spawn location of the Limbo world. But we're not done. When we teleport them, it'll just send them to the bedrock block, and that's all they'll see. What we actually need to do as well is get our fake block handler. Right. Equals NMS factory. Okay. So there's somewhere. So I believe we need to let me check my schematic handler in my prison core. Because we actually copied our fake block handler and then just changed it to be schematics. I might have some specific things in here. Okay. No, so I'm not storing which schematic the player is seeing. Oh yeah, I think I'm storing that elsewhere. So I think in our schematic manager we could do that. Let's go here. So instead of having our fake block handler here, I'm just gonna use our schematic manager. So in our schematic manager, we'll say minimize all that. Let's make a map, right? UUID string. And we're going to say player schematic. Well, actually, no. No, we don't need to do that. All right, that's what we'll do. When they leave and rejoin the server, we'll send to spawn instead of the Limbo world, or we'll send them to the actual spawn point if they're in the Limbo world. That way, we don't have to worry about automatically loading the schematic when they rejoin, because they don't need to be in the Limbo world if they rejoin. So that's fine. We don't need it. We don't need a storage schematic they're seeing. Well, you know what? We might have to actually. I'm trying to think exactly how I'm doing this, right? So if you send them to the Limbo world, it will only generate the chunks of the schematic that they have like within their render distance. So, and then after that, it won't try to load anymore. Because it doesn't know which schematic it's trying to send to the player. So we do need to do that. I think I handled that with, I mean, obviously I had to send packets to the player. Let me see. see, up, here. Heroes. Where did I write it at? All right. Right, where did I? No. You know, it might be. Right. The schematic ID is passed into there. Okay, so that means in my non-NMS classes, I pass the schematic ID in to our NMS stuff, and then that handles loading from that schematic. So, means in my main class, probably, or my main module, I did nope, it was in, it had to have been in a different module then. Probably my minds module, yeah. Yep, chunk load packet, alright. So the schematic is obtained from my player data. Yeah. So I store which mine type the player has, and then a schematic, and then that mine type has a schematic. So we do need to store which schematic we're sending to the player. So we'll just do that here. I was right. Initially, we do need to store which schematic we're doing. So in the constructor, player schematic, new hatch map. Void unload player, and we're gonna say player schematic, remove player unique ID. Okay. And then public void load player, and then we're gonna pass in a schematic ID, player schematic put, player schematic ID, and then we obviously need to not player D, and then I'm actually gonna say UID, and then we can copy this and put offline player instead of normal player. Okay. And then load player, and then we're gonna say public nullable string player schematic. And there we go. So this is nullable because they might not have a schematic trying to be loaded. And what we're gonna do is we're gonna pull from this get player schematic, and if it's not null, no matter what world they're in, we're gonna try to load or send the packets to them. Okay. So so that means in our command we want to say schematic manager instance load player and we want it to be schematic ID, in there. So, all right, now this is set up. We just say send player to schematic player, and then let's say schematic manager. Let me just, instead of having to call get instance every time, let's say schematic manager there. And then that. Get default schematic ID. And then schematic manager. There we go. Alright. So this is set up. This root command is set up. What we can do then is go and say, to add a subcommand, or our argument, we say private, because it doesn't need to be public. And then we're going to say required argument builder. Okay. And then we're going to say command source stack, and then string, because we're going to have a string argument here. And then we're going to say schematic. Okay. And then in here, we're simply going to say return commands dot argument. And then the name will be schematic. And then the type will be string argument type. And then dot word. Okay. Notice how it's not underlined red this time. Just because we're returning the builder itself, so we don't have to call dot build on this. Okay. And then we're gonna say executes context, return success. Okay. So now we can say copy this block of code right there. If it's not a player, so instead of select a schematic, we're gonna say select a player, because they're already selecting a schematic by this point. Okay. We're gonna say final string schematic ID equals string argument type dot get string, and then we're gonna pass the context in, and then the name of the argument, which is schematic, which we put right here. If you want, you can make it like a static variable up here. Private static final string schematic argument name. Okay, and then static argument name schematic. You could do that, and then that way you can pass it right into here and here. And if you ever want to change it for whatever reason, you only have to change it in one place, which is up here. Not necessary, but it does make it a little easier if you wanted to do that. Yeah, I'm just going to stick with that since I just changed it. So now we have our schematic ID from the input. And we could say, I think if it's null, I think we can check that. So if it's null, then we'll say player send message. We'll actually just say send player to schematic, player schematic manager, default schematic ID. Okay. And then we'll return success there. So if they didn't pass it in, if it's null somehow, it shouldn't ever be null, I don't think, but it's good to check, good practice. And then we should also probably check down here if schematic manager exists schematic ID. If it doesn't, then we'll just return. Okay. And then of course I'm gonna also check up here manually again. And then we'll say player send message and schematic does not exist. Okay. And return success. Okay. Then you can send player to schematic, player schematic ID. Okay. And I don't want to send that message down here because we could be passing a different player in the next argument. And that would make that player see the message instead of the person who executed the command. Oh my god, click to minimize. Yeah, this argument is done. And now to make sure that this is actually a part of the command, you just go up to our base command or our root node, and you can enter, and you can say .then, and then you can pass in schematic, the method. That's the method in itself, or technically you're passing in the required argument builder. It's constructed from this method. Okay, so now it'll allow you to type slash schematic or slash limbo and then the schematic. And one more thing we're gonna do right here is we're gonna say suggests. And actually, I want to make a utility thing for this. I'm gonna go down to utils. I'm gonna say brigadier utils. Final. Okay, private brigadier utils. And I'm gonna say public static. Let me. I don't want to forget, so I'm checking my version core. Okay. So we are returning a completable future, and that is of suggestions from com.mojang. Brigadier. So this is not NMS, by the way. So this is perfectly fine to have in your main plugin. Brigadier is actually a separate library that Mojang posted on their own GitHub. So it's not not very version dependent, unless they change it and use like a different library version in a later version. In which case, you might have some problems if you're trying to support multiple versions. But if so, then just put it in your NMS module, because we have NMS modules down here. It could technically be more than just NMS. You could put any version specific code in a specific version module down here. That's the beauty of multi-module projects, especially for multiple version modules. So you could do that if you wanted to. Very easy. And then we're going to call this method suggest. Okay, and then we're going to say final. No, we're going to pass in a suggestions builder called builder, and then we're going to pass in a collection of strings, and I'm going to call it suggestions. Okay. And then in this method, we're simply going to return paired suggestion provider from well, this one is a little bit NMS there, so you might want to put this in different versions after all, apparently. And then we're going to say that suggest and suggestions builder. See, the problem is I haven't tested my version core on any other version besides 1.21.10, which is the base version I coded it in, besides the NMS specific modules. So I might just end up moving this to its own NMS module. If you have problems with version support, best thing you can do is move this whole Brigadier Utils class to I mean, you should know how to do it by now, because I've done quite a few. You go to your NMS modules, abstraction, okay, and then you create a new interface right here. I might as well do it right here, just to show you. I'm gonna say Brigadier Utils, okay? This is an interface, right? So now we're gonna return. It's not gonna be static anymore, but that's fine. We're gonna say we're gonna return this right there, okay? And this is fine to put here because it doesn't have any NMS in this method signature. There's no NMS imports up here. That's what you want to avoid in any non-version dependent module. You want to avoid NMS imports. Okay. And then we can go down to our, well, first off, our NMS handler. We want to make another getter for our Brigadier Utils. Just like that. Okay. So you make the interface, you add a getter to it in your NMS handler, and then you go to your version specific module and you create an implementation of that. So Brigadier utils, okay? Be final, and then you implement Brigadier utils, and then you implement the method, okay? And then you simply say, right here, we're going to return exactly what we just wrote right here. Just like that, and we're done. So we can remove this old one right here. But what I'm actually going to do is I'm going to keep this static Brigadier utils class. I'm going to say private. I'm going to go above the private constructor because I like having static stuff above it. Besides, well, actually, yeah, I like having private variables above the. Okay. No, I changed my mind again. I changed my mind too much. We're going to have a instance variable for our Brigadier utils interface. And then we're going to call it Brigadier utils, and then we're going to make a getter for it, private static I Brigadier utils. Hello, welcome in. I'm making a Limbo plugin. It's supposed to be like Hypixel's Limbo, but not at all, because they have like different servers for their Limbos. I'm just doing a fake block schematic, sending it to them all in the same world, finding other players, etc. Instead of having their own world or own little lobby server, whatever. So yeah, we're gonna create a static getter, or getter utils, same thing as the variable name, and then we're gonna say if getter utils is null, getter utils equals NMS factory get handler get for getter utils, and then return getter utils. That way we don't have to get the instance of it from the NMS factory every time. We can just use the, and we're not actually going to use this. We're going to use the method. We're going to say return Brigadier utils suggest builder suggestions. Okay, there you go. So now we don't need to get our NMS version every time. We can just call this static one because there's no NMS imports. We're just calling a, I'm going to call this a bridge class. I guess. So we can still use just normal Brigadier utils. We don't have to get it from our NMS factory, and we don't have to type like the NMS stuff. The NMS part of it, we can just call Brigadier utils.suggest, which I'm going to do right here. I'm going to say in our back in our command above the dot executes, I'm going to say suggests, and then I want to say we actually need this here. We need the provider builder or something like that. No. So this is context and then builder. Context builder, and then you pass the builder in to the suggest builder. Okay, and then we want to pass the schematic IDs. So we'll say schematic manager get IDs. And now we'll have a list of all of the schematic IDs we can choose from when we try to type the argument. And I put this on a separate line just to make it less long, especially in our IDE, because it has these automatic, like, oh, this is what the this is. I'm like, yeah, I know, but fortunately the IDE just automatically puts this long string here, and it makes it hard to read, so I just put it on another line down here. You can even make it a little easier to read as well by having this parenthesis on another line as well. I'm gonna do that. Just so you know, like, this is the suggestion block, this is the execute block, etc, etc. And in our Brigadier utils, we can say we can create another method here. I'm gonna say, instead of a collection of strings, we're gonna say string ... suggestions. Okay, and here We're gonna return the same thing, except we're gonna put a list out of suggestions. You know, wrap it in a list out of. Okay. And then I'm gonna say another methods here. This one doesn't need to be NMS related. We don't need to put this one in our NMS version. Public static, not null, as you're gonna return a predicate of command source stack. I'm gonna say permission. I'm gonna call it permission. I'm gonna pass in the string of like a permission string. So we're gonna say return context and then a lambda. Put a semicolon at the end there. Say final command sender context get sender. If sender instance of player, then we're going to return true because the console will always just have access to it. And then we're going to say return player has permission and then check the permission string. This will return a predicate that will return this later when a player tries to run it. And I believe we could just say context get sender here. We don't need this variable. We're not using it for anything. All right. And then one more utility method down here. I'm going to say public static not null layer get target player. We're going to make a method to get a player from a player argument without having to type long code every time, right? So we'll pass in the command context, which is also command source stack passed in there. I believe we actually have. We even have the right. No, we don't have the right command source stack import. Sure, you're importing the paper command source stack, which is an interface, not the class one from Minecraft. Context, and then we're also going to pass in string argument name. So like the argument name could be like player or something. And then this also will throw a command syntax section. Okay. I'm going to say return context get argument name, and then we want a player selector argument resolver dot class. All right, and then enter. I'm gonna say dot resolve pass in context get source, and then dot get first. Well, oh no, it's just resolve there and then get first after that. So we can actually put this on another line there just like that. So we're passing the context from the command and the argument name, and then we are resolving the player from the player selector argument resolver, which is a paper interface helper for that. Okay. All right, it's all done. We need to go and actually change up our NMS handler to add that Brigadier Udals thing here. There we go. Private, final, not null, Brigadier Udals. Okay. Obviously return. There we go. So again, the only reason I put a Brigadier Udals in our NMS stuff is because the shared suggestion providers from net.minecraft.server, and I don't want to risk having version conflicts maybe on the line, just in case. But that's the only thing that was NMS related in our Brigadier Udals, so that's the only method I passed through. Okay. And again, we kept these static methods in our Brigadier Util's common class. That way we don't have to get the utils from the NMS factory every time. We can just call the static method here. Okay, so we're done with the Brigadier Utils utility class. Alright, so that was all just to make suggesting easier, and let me show you how you can add a permission requirement to any of these commands, or command subcommands, you know. So you just say dot requires, and then you pass in a predicate. So we made a method that returns a predicate in our Brigadier Utils. So Brigadier Utils dot permission, and we could just say any permission here now. So like Limbo dot schematic. I could choose which schematic to select. I'm actually going to say Limbo dot other, because this implies that they can send another player to Limbo. And then this command here won't have any permission requirement. The root, any player could just go to Limbo if they wanted to, without any like required permission. Although we can if you want. And all you have to do is, again, say requires permission, and then you can just say limbo.command or something like that for the permission. And then this is totally up to you. You can just add this to the default group or whatever other group you want. You know, whatever you want, you can have permission, and it'll work exactly how you want. And how Brigadier commands work is the command won't show up in the chat. So like if they were to start typing /limbo, it won't appear in their chat like for auto completion because they don't have permission for it. But if they, so it'll only show if they have permission for it. Same thing with subcommands or arguments. So now we have the schematic ID subcommand. We can now go another required argument builder, command source stack. And you might think we want a player argument, or that we're making a player argument, so we will want player here. But the reality is we actually want a player selector argument resolver here instead. Okay? And then we're going to say player. Okay. Again, return commands argument. We're going to say player as the command argument name, and then argument type. There is no like player argument type. It's actually a paper class that adds it. Argument types dot player. All right, and then executes context and success. All right, put a semicolon there, and this is now set up for whatever we need to do. If you're curious, you can check out what other argument types I have. So I have player, entity, block position, block state, double range, you know, a bunch of useful different arguments that just automatically like resolve in your command and handle invalid inputs for you. I'm going to keep player because that's what we're doing. My dog is laying under my desk. I'm trying to make sure he's not chewing on any cables down there. Okay. All right. So we already have most of the logic done for us. We don't need a suggests here, by the way, because some argument types just like already have suggestions built in, so it'll automatically suggest like any player that's online for us. So let's see. So what we need to do is basically the same thing here. We need to get the schematic ID, and we're going to check if it's null or if it doesn't exist, just like we did before. Okay, and we need the what I like to do in the final argument when you're selecting a player is say player equals context get source get sender instance of player P. If they are a player, or if the sender is an instance of player, then set player to P, otherwise set player to null. I'm gonna have a boolean here. I'm gonna call it isPlayer. I'm gonna set it equal to player, not equals null. So that way we know if it's a player or not. Okay. So I'm gonna go here and I'm gonna say if isPlayer. Well, actually, I'm actually gonna say this. If isPlayer, we're gonna remove the automatic sending them to the schematic. I'm gonna say player send message invalid schematic, and then pass in schematic ID there. Well, actually, it's null. I'm gonna say null, and then I'm gonna return success again. Doesn't depend on if the command executes like perfectly. It just depends on like it's more so like if they fail, you know, like if there's like an exception or something. I just like to return success because in Spigot commands, if you return false or something, then it like sends the usage message, and I don't like doing that. So I'm just gonna keep doing it like this, right? All we're doing is actually returning 1, because our success static final int returns 1, or is just 1. Okay, and then this implies that a player sent the command, and it returns if a player sent it, so that way we know right here that the console sent it. So I'm going to say plugin get logger info invalid schematic null. Okay, same thing down here. I'm going to copy this there. I'm going to say this time I'm going to actually pass in the schematic ID, because before it was null, so we couldn't pass it in. Okay, so there we go. We have our schematic checking, you know, if it exists or if the parameter is null in the command. Right, and we say file player target equals utils get player or get target player, pass in the context, pass in the argument name, which is player. And again, if you want, you can go up here and copy this. Let's say player argument name equals player. And then down here, player argument name. And then here, player argument name. There you go. Okay. So we're gonna say if target null, actually returns not null. So what we can say instead is if target is online, which they should be because it's a player argument, not a offline player argument. It might be good to check that either way, but I'm gonna leave it like this. It actually throws a syntax exception. I think what happens is that resolve. I think this will throw if the player they input is not online. So that already handles that for us. So we don't need to worry about that. So we have the target, right? I'm going to say send player to schematic target schematic ID. Okay. So that's all we need to do right there, I believe. And if you want, you can send the player a message, or I could go here. I could say if this player, and I can say player send message sent target get name to Limbo, okay, and then return success. And then if it's a console, we could say, of course, plugin get logger info sent target get name to Limbo. There we go. It's just some command feedback there. And I know some people don't like command feedback in the console. Like maybe you want to put this command in a menu and have a menu execute this command. You wouldn't want, and then allow players to click on it. You wouldn't want it to spam the console with a bunch of people clicking it in the menu. So what we could do is we can copy this, paste, and instead of a required argument builder, we're going to say literal argument builder. We're going to pass a literal in, and I'm going to say silent. And then instead of command star argument, we're going to say command star literal. And I'm going to pass in -s. Remove the second parameter, and we're good, right? And I actually want to return or remove all of this logic, and instead put it down here in a private method. I'm going to say handle other player or handle player argument. Okay, paste that in there. Don't need to return success or false because it's void. Okay. Okay, and then we need to pass in simply the command context, command source stack, default context. There you go. This right, this throws an exception and this does not. So we're gonna actually go down here and say throws command syntax exception, just like that. Okay, and now this is done. We're actually gonna pass in one more parameter. So I'm gonna make this extend it a bit, and I'm gonna say Boolean is silent, or just call it silent. Okay. So then we can go down here and we can say if not silent, then send it to the console. Okay. All right. And then up here we can remove all this logic because we just moved it, and we can just say handle player argument context not silent. Okay. And then same thing down here, except we're going to pass true in for silent. False. There you go. Now your actual argument methods are basically no code at all, and then all the actual logic is in this one method down here, which is the same logic that was originally here. We just moved it and added another variable, parameter. So now we have two arguments doing the same logic. So after player, we're going to go down and say .then silent. Okay, so now you can optionally add a -s at the end of your command to avoid console printing out any feedback. And then also in the schematic method, we have to go down here and we have to go say .then player. Okay. So now how it works is we have our root node, and then it has a second parameter or a second argument by saying .then. And then this argument now has a third argument attached to it. So you type schematic and then the player. Right? That's why it says .then. Right? And then you type the player, and then you can type -s to silence it from the console, or however you made the logic work. And obviously this method is already done. Okay. And our command is done, but we don't have, and it will send them to the Limbo world, and we can actually test this if we want. Oh, actually, we need to register it first. We need to register a command. So in our on enable, after we create our Limbo world, I'm going to go here, command manager, get instance, register, new Limbo command, and we're done. Now it's registered. Pretty simple. Build that. And taking a little while because it's been a little while since I built it. There we go, it's done. Should be able to copy that. Go there. Let's update our config. Remove the .skim. Save that. And we will run. Hello, welcome in Tobias. Prison plugin is alright. I'm actually using it as reference for this one right now. For this Limbo plugin, I should say. Yeah, it's alright. I just haven't had a little burnt out from working on it lately, so I haven't made a ton of progress as I initially did in the beginning of it. Kotlin? I'll probably never use Kotlin, to be honest. I used Kotlin before, but I think I prefer Java. Okay, so we're getting a warning from our NMS factory. It says run an unsupported version. Also welcome in Dev Mika. I can't say anything about Edward. If you didn't know, he was actually new to coding when he started making Edperson. And I actually helped him out with his 1.8 version forever ago, before Edperson 5.0. I was working on it as well a little bit. But yeah, he's a different guy. Obviously, he might not get as burnt out as I do if I work on something too long. If I work on the same thing for too long, and I hit a roadblock, I eventually get burnt out, and then I gotta take a break and work on something else. Yeah. Which is why I started a voxel game since I last made a ton of progress on Prison Core. Anyways, let's see. Right, we have some. Yeah, I'll finish it. I'm determined to finish it, because it's a good core. Like, I've never made a plugin so, I don't want to say professional, like professionally set up or anything, but you know, as I've never made a plugin as, in my opinion, well set up as that one. But yeah, and I know a lot of people need it and are waiting for it. So, or not a lot, but you know, quite a few. So I just can't make promises because it'll take a while. And again, it is just me working on it. To be honest, it's quite a feat that I managed to make so much progress by myself in only like a month and a half or two. Which never would have been possible without like ChatGPT, by the way. I use that as like a faster Google search, and it actually helped me figure out how to read the schematics in code and how to rewrite packet, rewrite the blocks in a chunk loading packet. Yeah. I don't copy paste though, and I don't use AIs like Codella where you type in a prompt and it makes the whole plugin for you. I don't do that. I think that's dumb. Have you ever heard of Nero-sama? Is a AI VTuber. The developer, Vettel, even he vibe codes Nero. But he has the same stance as me on it. You know, you don't, if you use AI to help you code and all you're doing is copy pasting, one, you're not gonna learn anything, and two, it'll just lead to a lot of errors and a lot of bugs that you'll have to go back and fix, and you'll be frustrated because you don't know how to fix them, so you're gonna ask AI to do that for you too. It's just not worth it. You have to kind of already know what you're doing or what the code is doing, and that's how I use it. I ask specific questions, being like, hey, how do I do this specific feature, right? and then I look at the code before I just, and again, I don't copy paste, so I type it out myself manually as well. There's layers to AI, There's definitely the wrong way to use it, but it's not like not the devil or anything. That's all I can say. Just if you want to see Neurosama, just look up Neurosama on YouTube. She's a massive thing. Like they're super popular. Like they broke the Twitch hype train record like once or twice. But yeah. Anyways, we're getting some. Yeah, I mean it kind of already is. So many people are doing. Edward. Edward Belt, because you mentioned him, right? His AI Codella. So many people are already using that. Oh yeah, dude, I had to be told to stop talking in his Codella Discord because so many people have a problem with me in there. It's crazy. I don't even say anything like I'm not toxic or anything. All I do is say like, hey, you guys probably shouldn't be trying to sell your plugins that AI made for you. It's the same case with AI art. You look at any artist on Twitter that posts, or not artists. You look at anyone on Twitter posting AI art and claiming that it's theirs, they get flamed. They get absolutely roasted. People don't like that, right? And that's exactly what these people using Codella are doing. They're typing out a prompt, having it make them a plugin, and then they're posting it on Built by Bit, and then they claim that they made it. They say, "Oh, I'm the developer. I made it." Yada yada. They don't say, "Oh, this AI made it for me." And you know why? Because I'm pretty sure it's because of me. I want to say it's because of me. I wrote to Built by Bit staff in a ticket, right? I said, hey, there's a lot of these plugins made by AI that people are making. I have proof. They claim in Codella's Discord that that's the plugin that Codella made. But they just don't say it on Built by Bit. So I reported that. And eventually they changed the rules because I mentioned that, hey, maybe people aren't going to like that they're being deceived by these people selling them AI products. Right? So eventually they changed the rules like, oh, you can't have plugins on there that are made entirely out of AI. Right? Yeah, people are just they're claiming that these AI made plugins are made by them when they don't know how to code. So, and that's the problem. Like again, there's layers to how to use AI and the incorrect way to use it, which those people are doing. You can't have it do everything for you. That's the thing. And if you don't know how to code, then you definitely shouldn't be selling it. Not at all. But yeah, so many people in the Discord have a problem with me, and I don't even say anything controversial. It's only controversial to them because they're such big users of the AI. Yeah, and me and Ed are friends. Uh, and he told me to stop talking in there because I'm like, all right, out of respect for you, Ed, and because I consider you a friend, I'll stop just talking in there in general. So, yeah, it's just so it's annoying. But yeah, you mentioned AI will be big, but yeah, that'll be. Um, Honestly, I've used a couple by now. I've used ChatGPT, and I've used Gemini. I have different opinions on them for different use cases, right? ChatGPT was good making bamboo. It was good at Java, right? Gemini wasn't bad either, but the problem was, my project was so big that Gemini I couldn't give all of it to Gemini to, for context purposes. So when I was trying to make a new feature, it's like, all right, well, this and that, and I'm like, no, that's not right. That's not what I'm trying to do, or whatever, right? Um, Claude I used a little recently, for my voxel engine, but I mostly used Gemini for that. So C++, I started a C++ project from scratch with Gemini. Um, that was pretty good. I think I tried to start it with ChatGPT, and ChatGPT was just failing so hard. It assumes too much. And then I moved on to Gemini, and it pretty much was very accurate for me. And then Claude. Claude is interesting. I've only used it like a very small amount, like one day. It only allowed me to send like 2 messages, at least on their like extended module or model, whatever. Like 2 or 3 messages before it's like, oh, you're out of messages. I'm like, okay, well, I gotta wait a couple hours to continue. Um, I've not, no. Gemini, ChatGPT, and again, a tiny bit of Claude is the only AIs I've ever used, really. That's because they're so accessible, right? Um, except for Claude. Claude is only allowed me to send a couple messages at a time, or limiting me. But ChatGPT at least has like a free model that you can send any amount of messages in, as well as Gemini. Also, ChatGPT and Gemini have given me a month free, like trials. And that's the only reason I was using them. Because the pro models are infinitely better than the free models. I'll tell you that, infinitely better. So if you're ever gonna use an AI for big projects, once again, don't copy paste. That's terrible. Um, read the explanations it gives you so you can learn. Um, and know what you're doing, right? If you are looking at an AI, like code that an AI gave you, you can read through it and you can say like, okay, well, that doesn't seem right, or hey, that's not what I meant, or something like that. Don't just copy paste because you'll have issues later on. I'll tell you that. But yeah, if you're gonna use it, use not a free model for big stuff, right? But yeah, I have experience with free ChatGPT plus ChatGPT. Uh, Gemini is a little bit different. They have like fast thinking, pro, or yeah, they have like different versions. Sorry, hold that thought. I'm getting a phone call real quick. All right. Sorry about that. All right. Uh, now I forgot what I was saying. Uh, yeah, AI. Wow. Okay. Unfortunately, it's I want to say it's already pretty hard to ignore it. Um, yeah. I mean, you can be stubborn all you want. Like, I'm a pretty stubborn person, I would say. I try to not use it much. Right now I'm making a Limbo plugin, like Hypixel's Limbo, because someone requested that I do like a tutorial or something on it. So I'm working on here. But we're getting this in our console when I try to start it. Right. We gotta fix this little warning here. Right here. So we could do a little bit of debugging here. Okay, you know why? It's because we didn't implement our specific version in our build. Yeah, but hey, Dev, if you remember what I was just talking about before I had to take a phone call, and you'd like to continue the conversation, let me know, because I can't remember right now. I just know it was about AI. And yeah, it's unfortunately a little hard to ignore it. Because I'm like right, I'm in college for game development. And so I'm wanting to go into that field as a career, right? So unfortunately, there's so much in the game industry about AI. You look at Microsoft and you hear news about them, oh, all of our game studios are forced to use Copilot AI for their, for their development process. It's not cool, but they want to prove to their shareholders or whatever that AI is good, it's a good thing. In reality, it's not really. I don't know. Again, there's a lot of ways to use an AI, and there's a lot of wrong ways and right ways that you can use it. Not like right ways, but I mean, there's definitely wrong ways to use it, and that's unfortunately what a lot of people do. They just want something quick and fast, and I mean, 100%. I'll admit right now, it definitely speeds up development time. But that doesn't mean you could just have it do it for you. Like, that's why I'm so against Codella AI, which, by the way, uses Claude and Gemini, as far as I remember. But the reason I'm so against that is because it makes it for you. You don't type any code. You don't code anything unless you're going in and manually changing things, which you can do. But that's not what many of these people do. Many of these people don't know how to code at all, and they just go to Codella. Another annoying thing is I see in the Discord all the time people begging for tokens, like free tokens. Like, it's crazy. Like, what do you think this is? It's a service. You gotta pay for it if you want to use it. So people don't even want to pay for the freaking AI. They just want to go in there, make it for free, sell the plugin for profit, and then probably not do anything if it starts breaking on people's servers. Anyways, I just find it really deceptive that, like, if I was a server owner and I was downloading a plugin I found on the marketplace, I wouldn't want it to be made by AI, especially if that person who posted it doesn't know how to code. Because if I have an issue, I can't go to the developer then and ask about it. Because they're not going to know how to fix it. They're going to go right back to the AI and ask about it. I've seen so many people talking about, oh, I spent so much code or so much tokens on bug fixes. I'm like, well, that's your own fault, man. I don't know. Anyways, so to fix this this problem, it's a class not found exception. We literally just have to add our NMS module in our build.gradle because we forgot to do that. So we add that line here, and we rebuild, and then that class will be in our project. I'm gonna stop server again. Built. Let's go ahead and copy, paste, run. There we go. Okay. Our plugin is enabled. So right now we're just testing the Limbo command. not the fake block loading, because we didn't implement any of that yet. Right, so this is just our manually built schematic here. So Limbo, right, there's a command, and we don't have any schematics loaded, it appears. Yeah. But if we were to type like any schematic ID here, we press space again, you can see we have a list of online players and entity selectors here, but you can't put like at A because it only allows one player, right? At E doesn't allow more than one player, right? Right, so you could probably do like a nearest player thing there. You could do at R, right? You could do at S, you could do whatever, or you could type in someone's actual name. That's what I like about Brigadier, that whole system. It does a lot of it for you. How Minecraft does it in their commands, like Minecraft :time, and then this is Brigadier right here. These are just literal arguments, and you set, and then you have another literal argument, etc., etc. Okay, so we are not loading our schematics right now, so I think the problem is in here. Schematic manager .get instance. We call get instance for the first time, and it will call our constructor. And then that will call on reload, which will load our schematics for us. So just add that one line and on enable. And it should load them. But we're not gonna see anything visually yet. Because we have to set up a bunch of packet related stuff. But our command should work now. Should have some one schematic loaded. Well, actually, we didn't put the schematic in here. So no, they're not gonna be loaded because we didn't put it in here. But it generated the schematics folder, which is a good sign. That means that code is running. So we're gonna go here, we're gonna copy schematics. We're gonna copy our limbo.schem from our fastest sync world edit. We're gonna go back here. We're gonna paste in our schematics folder. And again, limbo, no schematics loaded, right? And we didn't actually make a reload command, so I'm gonna have to restart the server real quick. Yeah, we'll make a reload command next. Limbo admin command. Final sends abstract command. Okay. Implement. Create constructor. Remove these. Don't need that. And say limbo admin. Let's selections. Singleton list. Admin limbo. Description limbo admin man. Okay. You can add multiple lines here. Okay. Alright, and then the root, I'm gonna make just a simple commands literal get name, executes, contacts, and then build. Okay. Turn success. Okay. If I'm gonna do a little timer here, so final long start ms system current time milliseconds. Then I'm gonna call limbo plugin get instance on reload. I'm gonna call make an end time equals system current time ls minus start ms. So that's how you get elapsed time for how long this specific code took to run. Right? Now I'm going to say if context get source sender instead of player to player. I'm actually not going to invert this because it doesn't matter. We're only going to have one thing in this block. But if it is a player, then obviously return success. I'm going to say player send message, Limbo reloaded in ms milliseconds, right? Okay, and then I'm going to do the same thing here. Limbo plugin get instance, logger info reloaded in milliseconds. Okay, and just for the consistency's sake, I'm gonna do that. And just call login there. Okay, and we have a simple reload command here. This calls our main classes on reload, which reloads our config and our schematic manager. Okay, I'm gonna build. Now we should be able to call reload whenever we need it. I'm gonna go down here. I'm gonna suffix this with dot disabled, just for testing purposes, right? We're gonna copy that, paste, yep, run. So we shouldn't have any schematics loaded because it doesn't end with dot disabled, or because it doesn't end with dot scan the file. And now we should be able to rename the file and then reload in game, and it should load it. All right. Limbo, no schematics. Okay. Go here. Schematics. Go to the topics. Okay. Limbo admin. Wait. Alright. I'm done. Got to register the command, of course. Just in a hurry to get the command working. It's fine. Alright. Literally. Nope. Alright. Command manager, register new Limbo admin command, and I'm gonna put it up there for that other one. It doesn't matter the order, I'm just gonna register it first because I like to have the admin command, like the main admin command, registered before the other one. It's just a me thing, doesn't matter. Okay, copy, there, run. There you go. Pretty quick to test small changes when you have a little folder set up like this. Okay. And again, we disable the schematic again, just for testing purposes. Limbo, now you can see we have both of them there. Again, no schematic loaded. Okay. Limbo admin. Reloaded 27 milliseconds. Limbo. Now we have, oh, okay. So it's using the path as the ID. That's not what we want. Okay, we gotta change that. Not an issue. Okay. Alright. Okay. Load path. Okay. Yeah, so it's using the whole path there. So path, the get file name. That if file name returns a path, so it's still a path. Well, This string ends with, okay, right, this is just filtering. We don't need it there, we need it, here. Load path sorry, file name. That should do it. And it loads, we might need the path. Okay, so the ID just needs to be different than the path, that's all. That's all. I keep this how it was. We don't, so we don't need to change anything here. We need to change in the loader, the ID that it's actually using down here. Schematic ID, right? Right here. Sorry. File name. There we go. Let's try that. We don't want the whole path to be the ID of the schematic. It's kind of dumb. Okay. And to optimize this a little bit, we're gonna, well, you shouldn't be able to have, okay, we don't need to check if it already exists. You can't have multiple files with the same name, right? So, unless you're not on Windows, I think you can, I don't know, something about that. Anyways, let's go ahead and, well, we know the reload command works. So we don't need to test that again. Okay. Okay, now we got an error. Does not return with an extension. Huh? That's weird. Alright, let's print this out. I'm gonna say git logger info like that. Um I don't think we had a file there. They were getting an index out of bound exception. Line 101 actually. Yeah, okay. Because I'm assuming because of substring stuff right there. So then we can't print that out there. Let's do file name here. File name, string, and we'll say file name for now. Since you already have file name right there, okay. So we should print it out right here then. Okay. Got tests. the file name is limbo.scam. Printing out correctly. That's the correct file name. Right here. So then what's the problem with this? Six is the correct number right there. Oh, this is why. Alright, there you go. We're just gonna do that. It should work. we were doing the wrong length. We're getting the length from the wrong thing. Fine. So make sure to get file name substring, not from the path. We don't need the path. We already have the file name. And then file name length -6 to remove the .schem, right? .schem, that's 6 characters. So we're stopping the substring 6 characters for the end. And alright, we got rid of the errors. Alright. So, Limbo. There we go. It did teleport us to the right block. But we are, notice how we are at 0, 0. And that's on the corner of this block. So what we actually want to do about that is change our spawn point by 0.5. Because I guess the blocks in Minecraft are offset by 0.5. Like the block grid versus the coordinate grid. So like full integer coordinates are not in the center of the block, they're on the corner of the block. So in our Limbo world, or our chunk generator, this is the get fixed spawn location, 0. 64, 0. We want 0.5. I'm gonna put D to signify double. Doesn't matter, but I like to do that. So 0.5D, 64D, and 0.5D. So that will put us in the center of the block. So there you go. But we don't need to test that. I already know it'll work. Don't need to test that. It's just a small thing. So let's start working on loading the schematic. Not loading it. We already loaded it, but loading, sending it to the player. I mean, it'll require a bit of setup. But once you know what to do with it, you'll be able to use it for lots of things. So first off, let's go down to our NMS stuff. Action. Okay, let's not start there. Let's start at Will Your Common. Yeah, okay. So let's go to our common. Not common module, but NMS common. Alright, and in here, we're gonna make a new package. But we are in the utils package right now, so let's get out of that one. Let's say .nms. I'm gonna make another another package called packets. Okay, so now we have 2 packages here. NMS and packets and utils, so we're separated out of that. Okay. We're gonna make some simple things here. So right now, let's start with an enum, a simple enum. Packet direction. What we're gonna call it. It only has 2 lines of code in here. We have server bound and client bound. Okay. So server bound means a packet is going to the server from the client, and client bound means it's going to the client from the server. Right. I believe we can do some Java doc on that. From client server this one obviously is server to client. If we hover over that, it now tells us that. Right. So that's an enum. We're going to use that later. All right. Let's do a. All right. So what we're going to do here is we need to let's check our player handler that we didn't make it. Okay. I'm following the same setup I made for my prison core, all right? So in our abstraction module, NMS abstraction, we're gonna go here, we're gonna make a player handler, okay? And of course, go down to our version module down here. Of course, we're gonna make a normal player handler, implements player handler, make this final. All right, in our player handler, we're gonna have currently 3 methods or so, a little more maybe. So we're gonna say inject, void inject, and we're gonna pass in the player to inject, all right? And then eject player, okay? And then we're gonna say boolean is injected player. Okay? So there's our 3 methods right there. And this will make sense a little bit, but we have, we're going to mess with a neti pipeline. And in order to listen to a packet for a player, we have to inject them into that pipeline. And when they leave, we obviously want to eject them from the pipeline. Okay. And then in here, implement those methods, of course. In our player handler, right. Okay, I need to make another tab, of course. Okay, versions, player handler. Okay. The player handler, we will have all right. So in the inject method, okay, we want an NMS player. So I'm gonna go up here. I'm gonna make a method private server player, right? This is the NMS server player object, right? Get player handle, okay? I'm gonna pass in player. So we're getting their handle up, okay? And return craft player. I'm gonna cast the player to a craft player, which is a bucket player, bucket specific class. And then we're gonna say dot get handle. Okay. So we're calling get handle from the craft player, which casts, right? So in order to call the method from the craft player specifically, we encase the entire cast in parentheses. That's what that's doing right there. All right. We're gonna say server player NMS player equals get player handle for the player. Okay. Then we're gonna say final channel. This will be a neti channel, I'm pretty sure. Channel NMS player connection dot connection dot channel. Okay, that's what we're getting. We're getting the neti channel from the NMS server player. Right. This is a server game packet listener implementation, and this is a network connection. That's why it's dot connection dot connection. Okay. So we have the channel, Then we're gonna say if channel pipeline get, and we're gonna have we're gonna go to our I guess I put it in here probably, our NMS handler right here. We're gonna have a public static final string. Not null. I'm gonna call it pipeline handler name. Okay. Let me make sure I'm gonna do the right name here. Okay, so the pipeline handler name, we're gonna just call it Limbo packet handler. Okay, that'll be the name of our pipeline. And while we're here, let's add a player handler object here. Player handler equals new player handler. And in our interface, you can control click on this. We're gonna add a not null I player handler. And then back here, we gotta obviously implement that method now. Return player handler, and we can make it non-interface version. And it'll automatically cast when you're getting it from the interface, so you don't have to worry about that. Okay, let's set up. Now our player handler, of course, right here we're gonna say NMS handler pipeline handler name. We're getting the pipeline from that name from the player. And we're gonna say if it does not equal null, then we will return, because it means they're already injected into the pipeline. Speaking of which, that can be that'll be our is injected method here. Copy paste that. And right here we're gonna say turn that. There you go. And the reason I'm not just calling is injected in here is because it gets the server player and the channel again. I don't want to have to do that twice in this method. So we already have it. I don't want to have to get it twice. I'm not gonna worry about that. Okay. So if they're already in the pipeline, just return it and do nothing. Otherwise, we're going to say channel pipeline add before. So we're going to add our packet handler before the other pipeline that's just called packet handler. And again, we're going to that's our pipeline handler name into there. And we actually need another object. It's going to be called packet channel handler for this player. Get packet. Oh, don't have any of that yet. So I'm gonna comment that out. I'm gonna comment this stuff out right there. And then we're gonna create that packet channeler, or channel handler. So in our back in our NMS common module, in our nms.package package, we're going to create a packet channel handler. And we might need another thing. Gotta figure out. Okay, well, for this, I'm just gonna say, this is gonna extend a channel duplex handler. And so this is essentially download the documentation for it. It's a channel handler implementation that represents a combination of inbound and outbound handlers. So it'll allow us to intercept both incoming and outgoing channels. Messages, right? So we have our layer here. Packet channel handler. Layer. Okay. Player equals player. And we had a dispatcher. So I'm just gonna make that, I guess. Here, I'm gonna make a I packet dispatcher. It's not an it's not the abstraction module. That's fine. The reason it's not is because abstraction depends on NMS common. And we need this in here, not in abstraction. So we can't have our common depend on abstraction. So if this was in here, then we wouldn't be able to access it, but you know. Right. So our iPacket dispatcher is a simple interface. It only has one method, dispatch, and we have don't need final player. We have an object. That's the message. We have a packet direction. So incoming or outgoing, or rather server bound or client bound. And then we have a packet context, which we need to make. So packet context is rather interesting as well. So let's create another class here. Packet context. And this will have, if the packet is canceled from being sent, and another boolean to bypass our packet listeners that we're going to create. Because what happens if we're listening for a chunk, like a chunk load packet, but we also send chunk load packets? We would be intercepting our own packets that we're sending, and that's not what we want to do. So we're gonna we have an option to bypass our listeners of packets that we send, so we don't overwrite the packets that we're sending ourselves with our own listeners, right? So make a constructor here, pass listeners, and so it's canceled. It's going to be set to false, and then this bypass listeners equals bypass listeners. Okay. And then we're also going to have another constructor that has no parameters, and we're going to say this false, so it doesn't bypass listeners by default. Okay. We're going to have a public boolean is canceled method, and a void is set canceled. Is canceled equals canceled. And a public boolean is bypass listeners. Turn bypass listeners. Okay. And then we're done with this class. Right. Okay. All right. All right. So now we have everything we need for this stuff. Packet dispatcher. So that's the other parameter that we're passing into here. It's the player and the dispatcher. Okay. So we have to override two methods here from channel duplex handler. We're gonna override the method called channel read, and that takes in two parameters. We have the channel handler context from ionity, those would be context, and we have the message that's being sent or that's being read. All right, and then we have our own packet context. We're going to create. Okay. We actually need. I knew this was coming. We need one more class here. I'm going to call it packet context carrier, like I did in my my prison core. And this could be final. So this is gonna I guess carry context information. So we're gonna say private static final not null map object of not null objects and not null packet context. So it's basically we're attaching this packet context to the object message, I believe. And we're gonna call this one incoming. And we're gonna make another one, and we're gonna call it outgoing. Okay. Static incoming equals new hash map, outgoing hash map. Okay. So we're gonna say we're gonna have a couple methods here. We're gonna static void attach outgoing. No object. I'm gonna call it the object of the packet. That's what the message is, by the way, in the channel handler. The object message is packet itself. And then we have packet context, our own context. Okay. So if the context, actually, yeah, we're gonna make this nullable. If context is null, then we're gonna return do nothing. Otherwise, we're gonna say outgoing put packet context. Okay. All right. And we're gonna have another one. Attach incoming. All right. It should be the same method signature pretty much. So I'm just gonna copy this one. And again, attach incoming. Incoming. There we go. Okay. Now we need to get them. So we're gonna create some methods here. Public static. It'll be nullable. Packet context. I'm gonna say we're gonna call it full outgoing. What that means is we're gonna return it, and we're also going to remove it from the map. So whenever we try to read it, it's gonna be removed automatically. So the packet. So from this packet, I'm gonna put this on the same line there. So from this packet, we're gonna say return outgoing dot remove packet, right? If it's not in the map, it's not gonna do anything. Remove won't do anything. But if it is in the map, it'll remove it and return it. And same thing for incoming. Incoming, remove. Okay, here we go. And now we're done with this class. It's a static kind of utility class there. Okay. So our packet context is, of course, packet context carrier. Pull, I believe this is incoming from the message, which is the packet. Yep, pull incoming. Okay. All right, and then we're gonna say if batcher dispatch player packet direction. This is server bound. And then context, right? I believe we need to make context knowable in the iPacket dispatcher. Okay. Right. So if not dispatched, then we're gonna return. Otherwise, we're gonna call it super channel. We call it the base channel read from the context and the message. And yes, this throws an exception. I think it throws, yeah, it just throws exception here. It says, all right. So that's our overridden method. So basically, what we're doing is we're overriding it, the channel read method, to inject our own logic here, and this will allow us to cancel sending it or receiving it. And then if we don't want to cancel it, we'll just have the base method run, which will do its thing, its own logic. Right. Then we're gonna overwrite one more method. It'll pretty much be the same thing. So we're just gonna say override public void write. Not called channel write. It's just called write. And then we're gonna pass in the channel handler context. We pass in the packet itself, which is the message being read or being written to, or being sent, I should say. And of course, it has a channel promise. Okay, this is the method that we're overriding. That's how I know the parameters, by the way. Okay. And this also throws exception. So we're gonna get again our packet context from our context carrier pull outgoing. This is from the server's perspective. Pull incoming to the server, right? Server bound. This is pull outgoing. So this is client bound. So if dispatch player message packet direction dot client bound, of course, packet context. If not, then we're also going to return here. But we're also going to say promise dot set success. Say that it succeeded. And then we're going to call it super. That's in the same parameters that we have here. Right. And now we're done with the packet channel handler. Okay. If you're not picking up my explanations, I apologize. I'm not the best teacher. I would really recommend diving deeper into packets on your own. I'm just following what I did in my prison core. But what we're doing is we're making our own packet listener system. So if you've ever used protocol lib, we're basically recreating that ourselves. Or maybe you've heard of packet events. We're basically recreating that system. I've never used packet events, so I don't know exactly how that works, but I know it works kind of like the bucket listener system, an event system. You know how you have like on player join events from bucket or from spigot, whatever. We're basically recreating that system, but for packets. That's what I did in my prison core because it's super convenient. It's easy to use. You'll see when we're done with this system. All this stuff is just part of the the back end of it. Think of it like creating your own library, your own packet library. Okay. So, the packet direction, packet handler. We don't have a that yet. All right, let's look at what we actually do here. Okay, we're gonna want this. Yeah, we're obviously gonna want that, but what do I want to do next? Exactly. We obviously need a packet dispatcher somewhere. Because we just have this there. We need to find. I'm trying to find where we actually implement that. Okay, well, here's what we're gonna do. We're just gonna go ahead and create the. We're just gonna keep going, and it'll fill itself out. Right. Actually, in the player handler, it should show what I'm using there. Player handler. Packet channel handler. Dispatcher. Okay. So in our NMS handler, we have a get packet dispatcher. So we're going to do that. Okay, so we have a class called a packet listener registry. That's what it is. In here, I don't know why I made it an interface then, but I guess it's because we don't need all of it. We don't need all of the packet listener registry. Man, these stupid Discord, man. There's like it's a stupid Discord that has one of those like fake ping badges because it's April Fools. But then they're like actually pinging people in there, and then it's like ghost pings. Really annoying. Anyways, packet listener registry. This will handle, I guess, registering any packet listeners that we create. So, man, okay. We need one more thing here. We need a couple things here, actually. So we need a packet. So we need a. I'm going to create another interface here called packet listener. And it's just an empty interface, right? It's a marker. That's what it's called. At least I'm like 90% sure that's what this is. Like an empty interface. It's just called a marker. You can say, hey, this class is a packet listener, pretty much. So that's all that is. And then we have a. We already have that. Okay. Here we go. So we're going to create another package in the packets thing. We're going to call it views. 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 We're going to create packet views. And that'll become apparent why later. Essentially, I can explain a little bit now, but essentially, what I want to do, or the goal of this packet listener system, is to not have to create packet listeners in our NMS version specific module. And what does that mean? Well, it might sound counterintuitive, considering considering the fact that we that they're NMS related, right? But in reality, Where did it go? In reality, the listener itself is going to go in our non-NMS packet modules. So, like, we'll have a packet listener in our main module. But the packet listener is not going to have any NMS related code in it. All the NMS related code of the packet listener will be in the NMS version specific modules. So we're decoupling there. That way, you don't have to write the logic for your packet listener for every specific version. All you have to do is write the backend logic of the methods that you're going to call in it. That's it. Like my... let me pull this up first, actually. SRC main here. Listeners there. So like my, I have in my, this is my main module, right? SRC is my main module. Listeners packet, I have a fake block break packet listener. This is what this is an example of what it might look like when you're making a packet listener after we create the system. Essentially, you'll create a constructor only if you need it. And then it'll be just like a bucket listener. We'll have any method you just annotate as packet handler, and then you can choose the direction that it's going. That has to be specific to the packet that you're listening to. So I can and you'll notice we're passing in. You would normally pass in an event, like player or block break event. Instead, we're passing in a packet, but we're not just passing in the raw packet. We're passing in something called a view, called a player action view. That's the packet we're listening to. It's not like any block break packet specifically that we're listening to here. But anyways, so we're creating a view that'll allow us to get the NMS specific things that we need to get without having to actually interact directly with the NMS code inside of this class. Right? That's essentially what we're doing there. Okay, so our packet view adapter is actually an interface, and we're going to say class. So we need which class is going to be the packet class specifically. So which class or which packet are we listening to? Okay, we'll have a nullable object to view, not null object NMS packet, not null player. We need the player for the listener or whatever, and we'll have a packet direction. All right. So this will allow us to convert any raw packet into a view. Okay. Just like protocol lib, they have I would assume technically wrappers is what the correct terminology would be. All right. And then we're gonna have a packet view adapter registry to hold our packet to view, right? Adapter. We're gonna restore the adapters to the packet. Okay. So we're gonna say private final, not null, map, and we're gonna do packet direction as the key. And then the value is actually going to be another map, but the key of this map is going to be class, any generic class, and the value will be packet view adapter. Okay, I'm going to call this adapters. Okay, packet view adapter registry, the constructor. I'm going to obviously make a new map for adapters. anyways, I have a register method. And we're going to pass in the packet view adapter itself. And we're going to get the bidirection map, which is from the adapters map. Adapters get adapter. Or actually, it's actually what I do is say adapters dot compute if absent packet or actually adapter dot direction. Okay, and if it is not already in the map, then we will say new hash map. So if this direction is not in the map, which there's only two directions, okay? So technically we could have two different maps here. I mean, we do have two different maps, but we could have like a incoming adapters and outgoing adapters map if you really wanted to. But I just used the one map in my prison core. I'm gonna do here as well. So the packet view adapter existing equals bidirection dot put if absent adapter an MS packet class and the adapter itself. If existing is not null, so if there was already one that exists, we're going to say throw new equal argument exception. I'm going to say adapter already registered for, and then we're going to pass the adapter direction adapter get an MS packet class plus let's say point existing dot get class get name. So we're just throwing that exception if it's already registered, or that yeah. Okay, and that registers our packet adapter to the specific packet that's trying to adapt. Okay, then we can go down and we're gonna make an adapt method. Mobile object adapt, right? No object packet player packet direction. So basically now we're going to take the packet and the player and the direction of the packet and we're going to well, we're going to return the view. So not the adapt. We're not going to return the adapter. We're going to return the view, which is obtained from the adapter. So packet view adapter by let's call it by class. Technically this is by direction. So adapters get direction. If by direction is null, then we're gonna return null. Okay. We don't have a packet adapter for that packet. Okay. Adapter. I'm gonna call it adapted. Get packet get class. So if adapted is null, if it is not null, we're gonna return adapted to view packet and the player. Okay, and we're gonna do for loop here. class packet view adapter entry by direction dot entry set. If entry get key is instance of this packet class, right? Then we will return get view value, get value dot to view packet player, right? So this is like a fallback of sorts, and then we'll return null at the very end. So it's saying it's gonna try to get it from the packets class. Otherwise, it will try to loop through the direction map to find it by the again the object itself rather than the object's class. Okay, so this class is done. We're done with that for now. We'll create some views later when we actually start listening or creating packet listeners. Okay. Now we can go back to our listener registry. All right. So we have our packet view adapter. Not adapter. Adapter registry. View adapter registry. We also have a map of packet direction class with a list of registered packet handlers. Alright, so we need a registered packet handler class now, which we don't have. So in here, new registered packet handler. Okay. Import list. Now we gotta fill this one out, but first we need to create a constructor. And we actually pass in the view adapter registry. Put that, and then handlers. It's gonna be new enum map, and I'm passing the packet direction class because that's what the key is. The key is an enum here, or packet direction enum. So we're creating a new enum map. All right. So our registered packet handler where am I? Registered packet handler. So we have the here's how we're gonna do it. Final not null. We have a packet listener. This is the instance of the listener. Then we have a method, which is from the reflection, right? From the reflect Java lang reflect package. Right. We also have a packet direction, and I added a packet priority as well. Go ahead and create that, I guess. Packet priority. And just like events, like normal events, we have lowest, low, normal, high, highest, and monitor. Just like bucket events, right? Now we're done with that. Now we can say packet priority. Now, I'm forgetting if I actually implemented like priority sorting for packets, but I might have ended up scrapping it or something. Right. Okay, and then we have a ignore canceled, so we can ignore if it's canceled or not. Right. No class, packet class. Now we have to create a registered packet handler constructor. Pass in the packet listener, the method that we're listening to, and the packet handler, which we also don't have. Okay. Alright, this is a simple annotation, alright? So we're gonna go here, create new, you're gonna go and create annotation, packet handler. Okay. And the annotation will have a retention of retention policy dot runtime. So it'll stay after compilation for runtime. And then target, it will target a method. So you can apply this annotation to methods. Okay. And of course we have the packet direction. We have the packet priority, which will default to packet priority dot normal. Then we have ignore cancel default to false. So you don't have to define these other two, but you do have to define direction, which we can rename this to value. So you don't have to specify direction when you're doing it. Like for instance, this here, packet handler. Now we don't have to say direction equals packet direction dot client bound or something. We just say packet direction client bound because it's called a value. Okay. But you will have to say like, oh, priority equals. You will have to say priority equals, or something like that if you want to add more parameters to it. Or we can just do that, or you can keep it as direction. You can keep this as direction and have to, you have to specify direction when you set it. But for now, I'm just gonna leave it like this. Okay, so we have our packet handler stuff there, and that was actually all of that. So again, registered packet handler. So listener instance equals instance. Dot method equals method. Direction equals packet handler dot value. Gosh. Priority equals packet handler priority. Or canceled equals packet handler dot again canceled. Packet class equals method dot get parameter types. Man, I don't know, I'm coughing. Hold on. Sheesh. Random coughing fit. Okay. I'm good now. I think. Alright. So, the class, the packet class, we're setting to the method's first parameter, but the type of that parameter. So that means when we create a listener, we have to specify the packet class That's the first parameter of the thing, just like we do in an event listener. And the last thing we want to do is set the method to accessible so we can access it. And notice how none of these are public or private. They're all package private. Not protected either. They're all package private. Okay, and same thing for this last method we're gonna create. Void invoke. Okay. You wanna pass in the player, the packet object, and the packet context. I'm gonna say throws a throwable. There we go. So if method parameter get parameter count is less than 3, then we will say method invoke for this instance packet and the player. All right, that means we're not specifying the context. Otherwise, we're going to assume that they're specifying the context in their method, and we're going to pass that in as well. And we're done. And I think I like to have that on its own line there. Okay, so we're done with the registered packet handler. Okay. Now this is not aired out anymore. We can go back to this. Which is this. Okay, now we have to make a register method. So we're registering a listener. We're going to loop through the methods in this class. The listener. We're getting the annotation from it. The method get annotation. Packet handler class. Okay. That's how you get an annotation on a method or any other thing there. If the handler is null, which means it's not annotated, then we're gonna ignore that method and move on. And then I have a couple helper methods down here. A private void validate method. Pass the method into it. So if modifier is public, and we pass in the modifier an int. We're passing the modifiers int. Then we throw a new illegal argument exception. Then we say at packet handler methods must be public. There are ways you can make it so that it supports like private methods. I don't know why I'm forcing it private, but I'm gonna leave it how it is. Parameters, method get parameter types. Okay, so that's what we're getting there. If parameters length less than 2 or parameters 1 not equal player class. So if we have 1 parameter or 0 parameters, or if we do have at least 2 parameters and parameter 1 is not a player, then we throw a new illegal argument exception. Method must be parameterized as packet player, optional packet context. There you go. That is done. So we can check it up here in our loop. Validate method. And we know that it's a packet handler method. That's why we're trying to, that's why we can throw these errors down here. Okay, alright. After that, you say class, packet class equals method get parameter types 0. Okay. Handlers compute if absent. Handler value, right? The value is the direction. We'll say new hash map. We'll say compute if absent again on that hash map. And then after we get that new map, we're going to add our new registered packet handler. And we pass in the listener, the method, and the handler. Okay. So what's going on here? Again, we're passing in a packet listener, which will be a class that implements packet listener. Then we're looping through the methods in that class. Then we're checking, does the method have, is it annotated with the packet handler annotation? If not, we're going to ignore it. We're going to do nothing with that method. We're just going to continue on. Then if it is annotated as packet handler, we're going to validate it. We're going to make sure that it's public and that it has at least 2 parameters, the second one being a player. And the reason we don't need this to be a boolean and we're not returning if it's false is that when this, if one of these 2 exceptions gets thrown, it'll immediately exit out of this this loop or this method here. Yeah, if you wanted, you could make it a boolean and then continue if it's invalid, rather than throwing an exception, and you still print out like, you know, whatever. But I find this easier. You're basically stopping trying to loop through the methods, I'm pretty sure. So you know, but you know, that's an easy fix, so it's fine. Okay. Then we're getting the class of the packet from the first parameter of the method. And then we're checking our handlers map. If the direction is not in the map, then put a new hash map in there. Okay. So it'll basically add this map value, like a new map, an empty map, as the value of that direction if it's absent. Okay. And then we're saying now this is now the value map right here, and with that map we're computing again, if absent, the class of the packet, and if that's absent, then we're putting a new array list as the value, an empty array list is the value. This will either return the empty list or the list that is already populated. And then we're just adding our new registered packet handler to that list. There you go. Alright, and now we have a couple methods as well. This actually is our packet dispatcher as well. We're going to implement packet dispatcher, and we're going to implement the dispatch method. So in the dispatch method, nope. Expand this to multiple lines for cleanliness. So in this, we're gonna find well, packet context, and I actually called this provided context here. Provided context not null. Okay, so if the provided context is not null, we're gonna say we're set it equal to the provided context. Otherwise, we're gonna create a new packet context. So we're not passing a null packet context in later in this method. So if we bypass the listeners, we're just going to return true right away. All right. All right. Then we're going to basically loop through things here. Well, actually, before we do that, we're going to say if. I guess we need another method down here. Yeah, to make it easier. Private Boolean dispatch object, right? Pass in the player. Pass in the object that we're dispatching. Packet direction. And the packet context. Call this packet context. Alright. So class list registered packet handler. So by class, right? We can actually just call this something simpler, like handlers or registered handlers. Yes. Welcome in. And that equals handlers get from the direction. Yes, it's a good game. So if these registered handlers is null, we're gonna return true. And we're returning true to let it pass through. To let it send, I believe. Okay. So now we have a couple for loops here. We're gonna loop through the map. And that will be there's our entry, registered handlers, entry set. Big loop conditioning. So if entry get key is instance of the object, and we're going to continue. All right, and then we're going to loop again. Registered packet handler entry get value. So now we're looping through the registered packet handlers for this packet class. Because you can be listening to this packet class in multiple different listeners, just like you can with events. Alright. So if entry if packet context is cancelled, and it's supposed to and it does not ignore the fact that it's cancelled, then we'll continue. I'm currently trying to code a plugin that emulates like Hypixel's Limbo, but not fully emulates because they have like their own like subservers and worlds and all that for Limbo. I'm just doing a single world with packet blocks. Yeah. And all that stuff. So, right. Now we have to try to invoke the handler. So I'm going to say try. Handler invoke. We pass in the player, the object, and the context. We catch the rowable, and then T print stat trace. And then down here, yeah. If you're interested, I have, well, what I'm referencing right now, code this is my prison core. It's in the works. If you're interested in any of that, I have previous live streams on my YouTube channel working on it, and also some showcase videos that showcase like the progress that I've made on it. If you're interested in another project that I was working on, a prison core, I have previous live streams working on it and showcase videos on my YouTube channel. And that's what I'm referencing to code this right now. Okay, so I do actually have some priorities here. So if the priority is not monitor, and it's cancelled, then we just return false. So down here, we return packet context is cancelled. This might recognize me. Oh, you mean maybe you've seen this older streams? Possible. I've actually streamed the making of 2 different prison cores. One, the most recent one was made from scratch. Yep. But I also streamed one in 2025 called Astra. But I restarted from scratch, and it's called Bamboo Prison. And I got way further than I did with Astra though, with Bamboo. So okay. So, now that this method's done, we can use this method in our dispatch method. So we say, if dispatch object, player, I call it packet. Oh. Oh, no, I called it message there. But really, packet. The direction. I did not make a new Twitch account, so maybe you either accidentally unfollowed, which is completely fine, by the way, or maybe you watched me on YouTube. I don't know if you watch live streams on YouTube, though. But fun fact, I do stream in a higher quality on YouTube, so if you're interested in that, I stream to YouTube on 1440p, while Twitch is only 1080, because of bitrate limits on Twitch. But you can watch whichever platform you choose. So I stream to both. If we don't dispatch the object, like if that returns false, and we also return false here. But if it returns true, we still have some things to do. So we got the view here. View adapter registry. Adapt the packet object, passing the player in the direction as well. If view does not equal null, then we will return dispatch object. Player view direction packet context. This will allow us to listen to like non-view adapted packets as well. And then down here we will return through. Okay. So there is another thing we need to do in here. Well, actually, there's two things. One of them's smaller. We need a sort all method here. Sort our things there. But don't have alert command, by the way. Don't. Is there a what does that normally do? I could probably make one at some point if you want that. So we have our we're sorting all we're looping through our handlers again by direction. We're gonna say by direction, not by direction. Handlers, sorry, got values. So we're looping through the values of our handlers map. Which is values is a set or a collection of all the values in the map, not just for a specific key. So we're looping through those. I'm saying final list registered packet handler the lists by direction of values. So now we're looping through the lists. Well, not the list. We're not looping through the list itself, but we're looping through the values of this internal map there. All right. So then we're gonna say list sort comparator.comparing. We have the handler, and I'm gonna say each.priority. So we're sorting them by priority now. And when we register, after we're done looping through all the methods, we're gonna say, well, sorting and adding to the handlers list. I'm gonna sort all of the handlers. That way they're always sorted by priority, and we only need to sort it when we actually modify the handlers map. So, all right, and we're not gonna unregister any handlers because, well, if you don't want to register some, just don't register, right? If you want to be able to do that, all you really gotta do is this, except remove here. You can try that. And then make sure you sort it when you after you remove as well. All right, so that's done, and we need to add bundled packets. Hold on a sec. I'm getting a knock at the door. Alright, we're back. Why my model is turned like that? Weird. Uh, very weird. There's some like keybinds or something here to rotate. Didn't touch anything. All I did was hold on. Let me fix this. What are the dang keybinds here? Here we go. That's weird. Okay, right, we need to be able to bundle packets together. That would be alright, where did I put this at? Okay, I put it in utilities. In our okay. Alright. Yeah, that's simple. Alright, utils. It's not at all. No. Alright, packet bundle unwrapper. It'll be private. Okay. And then public static nullable. An iterable of generic. And we pass in the nullable packet. So if packet with null, turn null. I'm gonna try catch here. Method, no, that method sub packets. Packet get class get method sub packets. Sub packets invoke packet. If result instance of iterable question mark it turn it. And we'll catch a throwable, we're gonna ignore it. And then return null. Okay. So somewhere I believe I created a little like a type of packet or something to bundle packets together. But I'm not sure where I put that at. Weird. Mature. I don't see that like any bundle class anywhere. Well, anyways, we have that on bundle unwrapper now. So we're checking for any method called subpackets, and then we are invoking that method for this packet object, and then that result is an object, and we're checking if the result, if that subpackets method returned an iterable of any type, and then if so, we're gonna return it. Otherwise, we're gonna return null, because you know. All right. In our dispatch, before we check if not dispatch object, we're gonna get that iterable sub the subpackets iterator. I'm gonna unwrap the packet that we're trying to dispatch. If it's not null, then we will say object, and again we're looping to the iterable object here, and we're gonna try to dispatch that one. We're gonna return false if it doesn't. Otherwise, we're gonna return true down here. All right. That should be all for the packet listener registry. And what are you complaining about down here? I think it's just print stack trace. Right. So this class should be all done. Now we're not doing anything with this packet listener registry quite yet either. We need here need our listener registry here. I'm gonna call it listener registry public player handler. Listener registry equals image handler get instance get listener registry. I'm gonna call it get packet listener registry actually. So in our NMS handler, we want our packet listener registry. Packet listener registry. Okay. And our packet registry actually has to be declared before our player handler, otherwise it'll null. New packet listener registry. And we need a view adapter registry as well. So let's go up here. Create a view adapter registry. View adapter registry. Okay. Okay. Packet view adapter registry. New packet view adapter registry. Doesn't need any parameters. Good. Now we can pass that in there. Okay. Or we could ignore this and say NMS handler. Actually, no, we can't because this is in a different module. That's why. That's why we pass it in. So here I'm gonna say it should be in the same package, right? Yeah, it's in the same package. So I'm gonna make it just a package private getter. Packet listener registry. Get. We might as well make a packet view adapter registry. Oh, that's fine. We know these are not null. I'm gonna call this just packet Right, we don't need to call, we don't have to get there because the other ones don't have get. Okay, now we have our listener registry, our player handler, and we need to pass that into our packet channel handler. Like that. Okay. Finally done with our player handler. Make that final, make it null. Okay, here we go. Our player handler is ready to go. Actually, we need to make the eject. We went on this whole side tangent to implement everything else we needed for the inject that we forgot to do the eject. But that's fine. The simple, pretty much same thing. Copy, paste. So, if we get it, then we're going to, I was gonna say invert that. Well, not it. You know. If they're not already, they don't already have the pipeline, then we can remove, and all we need to do is pass in our handler name, like that. There we go. Pretty much same thing except we're removing our pipeline handler's name from their channels, their channel pipeline. I'm gonna go here. I'm gonna create a send a packet method here. Gosh. Then we're gonna pass in the player, obviously. We need the packet. And we can pass in some nullable packet context. And we can make a overload here of that. We make a default send packet, player, packet, and null. So this default send packet that only has 2 parameters is simply calling this one up here and passing null in for the packet context. Now we only need to implement the one with the context parameter. Okay. And this will say if packet instance of packet question mark, which is from net Minecraft protocol, acid packet, then we will return because we don't want to send something that's not a packet. Then we're going to use our packet context carrier to attach an outgoing to the cast packet, and that's in the packet context. Okay. And then we're going to say get player handle player connection, send the cast packet. Right. Again, we're not actually attaching the context to the packet itself. We're storing the context in a map with the casted packet as a key, and then we're retrieving it when we're reading it later. That's what we're doing. It's acting like we're sending it with it pretty much. Okay. Should be done with the player handler for now. Okay. So in order to listen to a player's we now need to create in our main module, we're going to create a listener. So new package listeners down here. All right, we're going to say I'm actually going to create another package, events player join listener implements listener. Right, we're just doing a normal bucket event listener. Join player join events. So event get player. So what we need to do is get our player handler. Player handler is equal to our NMS factory get NMS handler get player handler. So use a player handler dot inject event dot get player. Okay, and now of course we need to event handler this, and we also want a public void on quit player quit event. We want our player handler to eject the player here. Okay, and handle that. All right, and then in our main class, we're gonna go down. Let's see. Get plugin manager. Manager, register events, new listener. Okay. I might actually rename this. So player channel. Player join play listener. Why not? Good enough. So now we're injecting them and ejecting them. We can listen to their like channel or whatever. Okay. With that out of the way, we can start actually creating. I believe we have most of the stuff we need. Right? We can store listeners, packet listeners. We can dispatch them. Yeah, let's just try it. Let's just make one and see what happens. So in our, well, in our version implementation, we're going to create a new package. I'm going to call it packets. Then we're going to say .views. In the views package, we're going to create a packet view adapter registrar. Not a registry, but a registrar. And the purpose of a registrar is to register things that we need to the registry. That makes sense? So in here, it's going to be a simple private packet view adapter registrar. I'm going to say public static void register. And we need our packet view. We should be able to get the view adapter registry from our NMS handler. Oh, right. I made them. Let's just make it public so we can actually get them. This is not in the same package. So, view packet view adapter registry. That's our registry. And now in this register method, we're gonna register all of our adapters. Yeah. And what we can do to make it easier on us as well is we can make a list here. Or a set rather. well, no, we'll do a list just in case you needed it to be ordered in a certain order. Packet view adapter called adapters, static adapters. These are listed of. So in this list, you'll call new on any packet adapter you may have. And then down here, adapters for each adapter. We can say register like that. Because the registry method takes in one parameter, and that's a packet view adapter, and this for each has one, well, it's a consumer. So it takes, it has the adapter that it's automatically going to pass into it. If this had two parameters, then you would need the lambda it. Anyways, that is the register method. We can go down to our NMS handler, and we can say packet view adapter registrar.register. Right after we create the registry. Okay. All right, now let's create some adapters, right? So I'm gonna go ahead and say I want to go see how which one we used for our fake block interact. Okay, because we're gonna need that anyways. So our fake block update packet, we use block update view. A block update view is client bound, so we're gonna go up to our Alright, we put them in here. So packet views, get a new package. I'm gonna call it client bound. And in client bound, we're gonna create a new class. It's gonna be called block update view. Okay. And this will have yeah, this will be a record actually, not a final class. We're gonna say record. If you don't know what a record is, it is a class that you pass parameters into, and those parameters will automatically generate a getter for them, and they're always going to be final, so they won't have any setters. So I'm going to say not null, client bound, block update packet. And that's the handle, what we call the handle. And this record will implement the, we actually need a, we actually do need in our abstraction, new package, packets views, client bound, I block update view, right? This is the interface. And in the interface, another tab here to check it out, right? So, NMS abstraction. Alright, the interface has some simple little methods. So we actually are going to do in our common real quick, we're going to create a little object that will hold a block post for us. And we don't need any, I'm not going to use any of the other, I'm going to call it simple block post, like I did in my core. And we'll just do a record. I get another record. So int x, int y, int c. Okay. And then we'll say that's all we're going to store. And we can do some little math with it, like simple block pose add. New simple block pose x this dot y plus y this dot z plus z, right? So the math, right? It'll return a new one for us. Make sure it's not null here. We can do this, whatever you need, whatever operations you want. We really don't need these, but this is how you can do it. All you do is you return simple block pose, and because these are final, you don't want to overwrite them anyways, you just return a new one, right? So there's an add and a subtract. We can do a multiply, divide, you know, whatever, but we don't even need these, to be honest. All we need is the dot x, the dot y, and the dot z that we can use. So that's all we need for that, and we're gonna use that in our iBlock update view. And this also extends our iPacket view. Can I create an iPacket view? Okay, yeah. Yeah. I created another interface outside this. Do that so I don't have to move the interface after I create it. I created an interface called iPacket view, and this is just another marker. Say that this is a packet view specifically. Doesn't do anything besides tell us that it's a packet view, and so we could pass it in to any parameter that's an iPacket view if we wanted to. Anyways, so simple block pose, get pose, right? And we have int x, int y, and int z, even though we have the get pose right here. It's just another thing we could do there. Yeah, so this block update view will be used in our, we implement it in our iBlock update view right here. So now we implement, we have get pose, x and y and z, right? So handle is the actual packet, right? And we're gonna return the information from that packet in here, right? So I'm gonna say final block pose, not that, handle get pose, right? Turn new simple block pose, get x, block pose, get y, get z. And if you don't want to have to create a new one every time, obviously you can cache this in whatever listener you want, but we can also do a constructor in here. It'd be public, I think. That's the problem. Yeah. If you create a constructor, you kind of have to have like that. So you have to have I think the right parameters, or you have to, if you're going to specify a constructor, you have to specify the constructor it expects as well, I believe. So we have the handle there. Now we can add, well, we actually can't add member variables in a record. So you know what we might as well do? Might as well not make it a record. Because a little bit of a hassle here. Yeah, let's do that. We'll just yeah, let's see this. Simple block pose, and we can just say simple block pose, rather block pose. Because we already have all the information even in the constructor here, so we can set this up like this. just like that. And now we can just simply return our simple block pose, because this isn't going to get changed ever if we already have this instance of it. So now we can say simple block pose X, simple block pose Y, simple block pose like that. Alright, that's all the information we need for the block update view, I believe. And we actually need to make a public not null client bound handle. Return that. Because this method is automatically created by a record. But we changed it from a record to a class, so we need to make sure that we add that method and get the handle. Alright, so now we can go to our registrar. A new actually, where's our packet adapter for this? So now in our block update view, we have this basically converts our handle our raw packet to the information that we need outside of this. In our main module, we don't want to interact directly with this class, so we create this adapter or this wrapper to get specific information that isn't NMS related. Like this simple block post class that we just created, it's not NMS related because we just created it, but this would return an NMS position, like an NMS class. Block pose is an NMS class, so we don't want to get that and interact with that. We create our own, and we simply return the data that we need. Alright, so now we actually have to make the adapter. I'm going to make an adapter here, or another class. I'd call it adapter, because we don't, it could be named adapter in all of them. So it implements packet view adapter. We need to override these three classes here. So get NMS packet class is obviously client bound block update packet class. Okay, and then the to view just says new block update view with we passed the NMS packet to client bound block update packet like that. And this is actually supposed to be not null. Go to the implementation or the interface of it by clicking here, and we can say this is not null. We can go back down. Okay, this is not null. There you go. That's what it's complaining about. Yeah. That's all it's complaining about. Okay, and then the direction is obviously client bound. Okay, client bound block update packet. Okay, that's our adapter. That's all we need for the adapter. Now we can go to our registrar and say new block update view.adapter. Put it in our list here, and it will automatically be registered in this for each loop down here. Okay, so now that we have that, we can go down here. Listeners, I want the instead of events, we want packets. I mean, listeners events packets. So in our main module, of course. Now we can make a packet listener here without having to interact with NMS code in our main module. And we don't have to create this listener in each NMS version module. I'm going to call it big block interact packet listener. It's a mouthful, but it works. We're going to get our... Also, the music ended. Streaming so long. Go ahead and restart this. There we go. We want our probably our schematic manager, or rather, we might not need that. We might just need our well, yeah, actually, we do need that to get the schematic of the player is currently at. And then we need our big block handler. Okay. And then we could do a public fake block interact packet listener schematic manager equals schematic manager instance handler equals NMS factory. There you go. Okay. Now we want a packet handler annotation, right? The one we created. And the direction is packet direction dot client. Okay. Public void on block interact. Okay. And we don't use the packet class here. We use a block update view that we can call it packet, but you know, we know it's a view. And the player there. Okay. And I want to say we don't need the oh, I guess we do use in my prison code I do add the packet context here. Alright, so again, exactly like a bucket event listener now. Create the method, and then we create our logic in here, and it will automatically register, well, we'll listen for that. Oh, whoops. Gotta handle that on. Anyways. No wonder. It's all laying there. Bad. Anyways, let's see. When I fix my model, I forgot to toggle it off. Must have been annoying. Okay. Alright, so we have our packet get packet X, Y, packet Y, right? So now we have all the information we need. Now we know which block they're trying to interact with, right here. Or we know what the location of the block that they're trying to interact with. We don't know which block it is yet, because that's in our fake block handler. we can go here and say, string schematic ID equals schematic manager get player schematic for the player. If schematic ID is null, then we'll return to do nothing. We don't have to worry about it because they're not added schematic. Okay. And then we can say our big block handler get big block for the schematic ID at X, Y, and Z. This will return an int. Right. So this is our block state ID. You remember from the last stream we created a block state registry. Which we don't actually need check the we don't actually need to check which block it is. But we can for for debugging purposes. We can say block state registry block state to material block state ID. That's the material block that we're interacting with. I'm gonna go ahead and say player send message big block material. Well, actually, right here, we're gonna say if block state ID equals -1, we're gonna go ahead and return and do nothing because it's not a fake block if it's -1. And I actually kind of want to do a int get invalid. I'm going to do this in our getter here, or our iBlock state registry. We're going to go here, we're going to return, and we're going to implement that method. And then I believe we have big chunk section container dot empty block is our global variable for, you know, I believe we want that there as well. Okay. Yep. So we're just getting this. So now we can actually check. Get invalid block state ID. So now we don't have to hardcode -1. We can change it whenever we want by going here, implementation, empty block, clicking on that. It's in our fake chunk section container. There. Oh yeah. So you can change that to a different ID if -1 doesn't work for you, which I mean it should. What I mean by that is if you don't prefer -1, but you can't use like a positive ID though, because that most likely it'll be a specific material that already has that ID. Or you can use like a super high number, but I would just stick with -1. Okay, so that's our material and stuff. So this is just for debugging purposes. What normally you could do is say is fake block, and then just return if it's not, right? If it's fake block, return, like that. That's what we'll do when we're done with debugging. But we also need to context is cancelled, set canceled true. Because if it is a fake block and they right click it, we don't want it to disappear when they do that. So we have to cancel the packet from being sent. Okay, so this is all we need in our fake block interact packet listener. So in our plugin, we're gonna go and gotta register it. Which, let me remember how I do that. Okay. We get our packet listener registry here. So we have access to it in our main module. Animus factory, get animus handler, get packet. Did we not create a getter for it? I guess not. So let's go back there and do that then. Or maybe we did, we just didn't put it in the interface. That might have been what happened. Yeah, we need to do that. So take this, override, go back to our thing there, and we will place that there. Here we go. Right. And again, the abstraction module here, it depends on the calling module. This NMS calling module. So it can use this without having to have an interface in here. But we do need this getter in this INMS handler interface in order for us to get it in our main plugin. Packet listener registry. There you go. So now, register new big block interact packet listener. And this, right, this needs to implement, right, because bucket, bucket listeners, implement listener. We're gonna implement packet listener, which again, it's just a marker. It doesn't have any. This ours doesn't have anything in it. It's just a marker to say, hey, we're registering specifically a packet listener here. There you go. Now we've registered our packet listener, just like a normal bucket listener. That's what my goal was for this packet listener, like creating my own packet listener stuff, was to make it work exactly like a bucket listener system. Okay. So hopefully that should work, but we still don't quite yet have a way to actually load the schematic to us. We have no way of actually testing this update thing yet, but we did need it. We did still need that. So let's. Oh gosh. Okay. Let's see. Another might be a little bit of a big undertaking here. Not as big as this packet listener system. So you've made it through a big hurdle there. You're still here and following along. All right. Also, if you guys don't want to use fake blocks, that's totally fine. You could use like a real schematic in a real place. As Limbo, but you do still need to hide players. In which case you can say like player. Right, so player hide player. So you pass in the plugin, your plugin, and then you could loop through all players and do that. So you could do it that way, but it does remove players from tablets. Which, if you're emulating so exactly, then you can do that. But I went for an optimized Limbo with multiple big blocks and stuff. I guess in hindsight wasn't necessary. I'll create another tutorial, I guess, for a more simple one, because you definitely don't need all this, I don't think. But anyways, big tutorial, packet listener system, big blocks, sending them, I guess. I don't even know if I would call this a tutorial at this point. It's just been such long streams of, figuring it out, really. I guess we can call it figuring this out, and then I can make an actual tutorial, like a shorter one, maybe. Anyways. Let's go down to versions, down here. Okay. So in versions, I'm going to create a new package finally. I'm going to call it Eagles. Okay. This class can be made in common. We don't actually need our NMS common down here. I'm going to go here. I'm going to call it IO friendly byte buff. Okay. And we're going to have 2 friendly byte buffs in here. Actually, it's public. Friendly byte buff in and out. We're going to create a constructor here, and we're going to pass in no friendly byte buff, original buff. Okay. So with the original byte buff, friendly byte buff, we're going to do length, original buff capacity. And the raw bytes is new byte array of size length. And then the original buff, we're going to say get bytes of 0, or starting at 0, and then pass it into the populate the raw byte array. And we're say in equals new friendly byte buff, unpooled from ionity buffer dot wrapped buffer. I suppose that's maybe that's why I did it in the specific version, because friendly byte buff is NMS code. So, technically, pass the raw byte buffer into there. We're gonna say out new friendly byte buff, unpooled buffer. And we're gonna pass in length plus 1024 there. Public not null byte buff in. Even though they're public, I'm gonna create getters for it. Ouch. Turn out. Okay, and yeah, I'm just gonna move this utils down here instead, because this is in fact NMS, and you don't want to. I'll keep that in the version specific module there. Okay, we're gonna use this in our chunk listening packets. Let me just go ahead and close down all this stuff. Alright. So other utilities we're gonna make, we need a, oh my, okay. We need a chunk packet block entities. We're gonna essentially create our own here. Not create our own, but some utility methods for this related thing, right? Because a chunk can have data on the entities inside of it, so but what we don't want is, or we don't care for those. So I created this to ignore that basically. So network protocol game client bound level chunk packet data, and then a $sign block entity info. We're getting this is the path to a class inside of a class. Block entity info class inside of client level chunk packet data. I think this is what? I think this is supposed to be reading the block entities. But didn't we not care for that? Didn't I just say that? I don't even know. I want to say I don't know if we even use that. I think, this has been a 4-hour stream already. I think we pause here and do a part 3. Or I'll do I'll ask you guys just now if you're still watching. Do you want me to continue part 3 with all this complicated stuff? I assume so, but I could also ask, I also raised this question. Would you rather I start fresh with a real block implementation? Because if you think about it, if you really think about it, what is Limbo? 9-pixel, right? You get sent to Limbo with the same schematic. It's the same schematic every time you get sent to Limbo. And that's all we need. We could just paste that, right? You just paste that in that location in the world to that thing. And then all you would need to do really is hide players from each other when they're in that world. I don't know why I initially said packet stuff, to be fair. We'll see. But we're gonna pause it here. I'm gonna look over everything here because there's a lot of when it comes to rewriting chunk data, which is essentially what we had to do to paste to put the fake blocks in. Uh, what we're doing essentially is listening for the client bound. Let me see. Level client bound level chunk with light packet or something. I can probably check it here. Client bound level chunk with light packet. Yep. We're listening to this packet here, which is sent to the player whenever a chunk loads for them. And it contains all the information from the mobs in the chunk, the light values for every block in the chunk, palette of blocks in the chunk, and the what? And yeah, just all the blocks basically. And essentially, what we have to do is intercept that chunk load packet and rewrite what is in the blocks. So we're overwriting the blocks in the packet, which is essentially the same kind of concept that we did with the schematic loader, where you have to read through like the file, except we're not reading through a file, we're reading through still byte data. But yeah, so there's a lot of like formatting you have to ensure you get correct. But yeah, I'm gonna edit here because my mind is getting all foggy from just keep going, like going for 4 hours now. And let me tell you, I went to bed at like 2 a.m. or so, or I fell asleep then. I woke up at 8, and then I did more work outside this morning till like 11. Oh, yeah. But yeah, I really wanted to get a stream in today at least, so this is good. Again, I wish I could be I wish I could explain things better than I'm doing. Doing a lot here, but let's see. Can we actually? Maybe we can check another packet before we go to make sure that our packet listener at least works, right? So let's do that before we end it. Let's just do that real quick. So client bound. Let's say let's do a move entity view. Or actually, no. We can check we can use block update. Yeah. It doesn't have to be fake blocks for the block update. I don't know why I was thinking that. No. All we need to do is go to our listeners packets, big block interact packet, and we get to say, we can say this. Let's take all this. Oh wait. Well, let me copy, and then let me do that. Okay, we're gonna leave all that uncommented for now. Say our coordinates. Player get world. Get block at X, Y, and Z. So block. And I believe this shouldn't. Right. So I think this is technically like bucket related code, so you have to have to run it synchronously because you're interacting with like bucket stuff, like world and stuff. So Limbo instance. We're gonna do that. We're gonna put it in a scheduler run task, right? Because again, we're interacting with, we're getting in the world, we're getting a block in the world, we're, you know, so we don't want to do that asynchronously, which packets are done asynchronously, or at least they're not done on the main thread, right? So we have the block, but I don't think this can return. It returns not null. So material equals block get type. Player send message acted with material to string to lowercase. All right, now we can test this out, I think. At least proof of concept, right? Okay. Go. So we went up by like 30 kilobytes by running all that. Run. All right. Okay, here we go. All right. Hopefully this works. Yeah, there you go. Look at that. We interacted with Bedrock, Bedrock, and Air, even though I only clicked once. So it'd be good to keep that in mind. You know, this 4. Okay, so right, so if you place it on something, you're interacting with the 7 block. If I break it, it's just interact with air. So it's very interesting. Oh yeah, I think it's because it's a tick behind, and the block that I just interacted with, Bedrock, broke and is now air. So yeah, but it works. We're listening to the packet and we're printing it out in our listener. There you go. You now have a good system for that. So yeah. Anyways, that's where we're gonna leave it. Okay. All right. So, yeah, we can come back to this another time. I gotta take a break. I don't know if it's just me or what, but if I'm coding too long, eventually I just can't code for like all day. I mean, I can if I'm like, I don't know. If I'm in the zone, I guess. I have coded all day before. It's just, yeah, I don't know. I think I need to start sleeping better. I think that's the thing. Anyways, all I did was revert this. I just reverted this. These are NMS stuff there. And we're not interacting with the world here. We're interacting with only our stuff, so like our fake block handle or our block state registry. So this could be asynchronous. But again, we don't have any fake blocks sent to the player. So when we try to check that, it won't. Well, I guess we'll see. Anyways, this is where we're at. I'm gonna build that. Just why not? All right. If you're interested in more, more coding streams, I do them from time to time, of course. I also do game streams. I've been streaming Subnautica recently. It's not my first time playing it, it's a revisit in preparation, I guess, for Subnautica 2 when that comes out. I do have a Discord in the YouTube stream description or on my Twitch homepage. I have, again, I stream on both YouTube and Twitch, so choose whichever platform you prefer. Although I do stream on YouTube at 1440p, while Twitch is locked at 1080p. So, something to think about. Subscribe. Yeah, that would be nice. To the YouTube, trying to get the numbers up. And follow on Twitch if you prefer to watch there. Okay. I think it's everything I have to say. Thanks for tuning in, everyone, and chatting. If you have any questions, like if you're watching live and you ever have any questions, feel free to ask. I'll try my best to explain it. And if you're watching afterwards, put the questions in the comments or join the Discord. You can ask there. And I'll answer either in the comments or on Discord or in the next stream. Yeah. Let's see. I think that's everything. Yep. Thanks again for watching. I'll see y'all in the next one.